So this video is going to go through question 5 of sample paper B. So it tells us shown below is a 3D model of an automated car barrier. Part A tells us the elevation of a parking token for use in the automated car barrier is shown below. So we're looking at this picture here. Part 1 of A is identify and name 2 different polygons used in the design of the parking token. So we can see here we have 1, 2, 3, 4, 5-sided shape. So that's going to be a pentagon. And then for our outer one, it's 1, 2, 3, 4, 5, 6, 7. And that's going to be a heptagon. So for part 2 then, write the measurements of A, B and C in the space provided on the right. So you need to actually measure them out. So A, use our set square. We measure our distance there. And that's going to be 25 millimeters. So make sure when you put in 25 you put in mm to show the unit of measurement then. B then is going to be an angle. So we know with a pentagon our exterior angle is going to be 72 degrees. So this time we're going to be measuring our interior angle. You can see the interior angle, 72 degrees. Sorry. Starting from here, 0 all the way around. So it's going to be 108. And then put in our degrees sign there as well to show that. And for C then, same thing again. Measure the length there, and that's going to be 15 millimeters there. So that's part A complete. Part B then tells us an incomplete elevation of the car barrier in the closed position as shown below. Part 1, divide the arm of the barrier into 12 equal parts to complete the elevation. So basically like this here. So what we need to do is, we can take a line at a random angle and step out 12 equal distances. So that's the equivalent of me going 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 12 equal parts. Then we need to do is use the sliding set squares, go to the end, connect the last one, and then slide back for each one like this here. So using sliding set squares all the way back for each of these measurements. Then we can do is take them straight up and draw them heavy where they need to go. Like that there. And then for part 2, it says show the arm of the barrier in the open position by rotating the arm about point O until point A reaches point A1. So if you imagine putting your pencil there and the tip of the pencil is at point O, we want to rotate that around until it touches off A1 like that. So when we rotate it around, it's in a circular motion. So what we can do is we can take the distance from O out to A, and we rotate that around, you can see it hits off A1 there. Now what we've done is we've moved OA to OA1 like that there. Now it's now rotating all the other points. So if we look at this here, this side here is at a right angle. So it's perpendicular to that line. That line's now been rotated there. So what I'm going to do is go perpendicular to that as well. And when we're rotating everything, the shape is not going to change. It's going to stay the same size. So when I line that up there, that's going to be perpendicular there, and also this end here is going to be perpendicular as well to represent that line rotated. What I can do then is I can measure the distance each side. So they're 5 mil each side there. So I go 5 there, and there, then go 5 there, and there, and connect them together. Now I have the actual outline of the barrier, so what I'm going to do is rotate each of these points up. So instead of taking all of them top and bottom, I'm going to take just the top points. So if I rotate this one here, that top point, I rotate it around until it hits the top there. And I do the same with all the rest of them. And then they go perpendicular to that top line there as well. So that's part B now complete. Last part then is part C. It tells the stop sign based on a regular octagon is to be added to the car barrier. Inscribe the shape of the stop sign within the circle on the right. So we know from octagons they can fit inside a circle, and a circle is 360 degrees. There's 8 sides in an octagon. If we divide 8 into 360, we get 45 degrees. So what I can do is go 45 degrees each side there and there, and take my vertical horizontal lines there. When I connect those all together, it's going to give me my 8 sides. They're all equally spaced apart. And that's basically inscribing an octagon into a circle. So hopefully that video helps anybody maybe stuck on any of the parts to question 5 there.